Hi, welcome back. We have note 7-3 today, and it is page 13 in your note guide. Hopefully you guys all have your note guides picked up. We are talking about properties of rectangles. Now the nice thing about this is that rectangles have all of the same properties as parallelograms. So we had 5 things the other day. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. So, opposite sides are parallel is basically the definition of a parallelogram. The other 4 things are the additional things you know about parallelograms. So, rectangles have all of those properties plus 2 more. So all of these are things that we already were studying with parallelograms. Plus, with a rectangle, instead of just opposite angles being congruent, all 4 angles are congruent. They are 90 degrees. They are right angles. Okay, the second thing that is in addition to parallelograms that a rectangle would have is that not only do the diagonals bisect themselves, the diagonals here are now going to be congruent. So I could draw a rectangle over here to kind of demonstrate for us that in an actual parallelogram, opposite angles would be congruent, but in this case, all 4 are going to be right angles. And then, in a parallelogram, the diagonals would bisect each other, but here, the diagonals are actually all the exact same, and because they bisect and are congruent, that means all of these pieces are equal to each other. So if you know that, go ahead and pause and see if you can answer anything you know about 1 and 2. Pause and then come back and check. Okay, so what I personally do is usually I go through and I label everything I know, then I see if I answered it. You can always start with the questions if you want, but I usually start with the picture and write everything down. So QR has to be the same as PS, it's going to be 10 over here. SR is the same as the top, so it's going to be 24. Now SQ is a diagonal here. Notice that because this is a rectangle, we're going to have a right angle. I have a right triangle right here. Anytime I have a right triangle, I need to find a hypotenuse, one of the legs. My favorite formula is going to be Pythagorean theorem. I'm going to do 10 squared plus 24 squared equals c squared. I end up with 676. And if I square root this, this is actually a perfect square, which is pretty nice, and it's exactly 26. So SQ, the entire length, is going to be 26. And then PR, because the diagonals are congruent, PR has to be the same. And because they get bisected and cut in half, if I'm looking just for QT right here, I'm going to look for half of 26, that'll be 13. So good job, those of you who got those right. Again, pause and do the second one if you haven't yet. AC, well if this is 15, this is also going to have to be 15, so AC would have to be 30. BD right here has to be the same thing. Diagonals are congruent when it's a rectangle, so this will be 30. BE is going to be the half, it's going to be 15. Now AB has got to be the same as the opposite side, it's going to be 27. And then BC, I don't know yet, but I just used Pythagorean theorem over here, probably going to use it here. I have this whole length is 30. And this is 27, this will be my x. I have x squared plus 27 squared equals 30 squared. I use my calculator. 30 squared is 900 minus 27 squared. I end up with x squared equals 171. And when I square root this, I get x is approximately 13.1. I usually go to 1 decimal in these cases. Depending on what Alex asks you to do in your homework and things like that, you can do it different ways. Okay, right here. Now angles. M, J, K. Well, that's a rectangle. It's got to be 90 degrees. M, J, L. Well, if this is 27, I'm going to subtract from 90. I end up with 63 right here. I have J, L, K. So now remember, we have parallel lines cut by a transversal. So if I have parallel lines cut by a transversal, these are alternate interior angles. That would also have to be 63. KML. Now again, if that's 63, and this is 27, and this is now, if I think of this, these are all the same, that makes these isosceles triangles. So if this right here is 63, this over here has to be 63. The opposite angles have to be congruent because they're isosceles triangles. Here I have isosceles triangles, so if this is 27, this has to be 27. Those two have to be 27, these two have to be 63. So I know all of those. And I was looking for KML, that would be 27. Now the next I'm looking for is M, N, what is it, M, N, L, right here. So what I would do, and there's lots of different ways you could do it, is I'm going to use my triangle sum. I'm going to take 180 minus 27 and 27 is 54. I take 180 minus 54. I get 126. Well, if this is 126, this up here would be 126. And I could also subtract that from 180, and I would get this angle right here to be 54 and 54 because they're a linear pair. So there's lots of different ways you could do these. See if you can go ahead and work this one out on your own, and I'll give you the answers in just a moment. Okay, so right here, if this is 64, this is 64. And I'm going to use, I'm not even going to look at this first. I'm going to fill in everything I know. If that's 64, that's 64. This right here, subtract from 180, is going to be 116. Well, if I do 180 minus 64, I get 116. So 116 is left over for these two angles. I'm going to divide it by 2. If I divide 116 in half, I end up with 58 here and here, which means those are going to be the angles here and here as well. Well, now, if I did 116, subtract that from 180, I'm going to have to divide by 2 to divvy it up because, again, it's an isosceles triangle. So 64 divided by 2 is going to give me 32 here and 32 here. Now, how else could I have done that? Could I have known if that's 58 that these two have to add up to 180? Or, sorry, 90? It's a right angle. They'd have to add up to 90, so it's a separate way to do it. So what's really nice about this is that if you know the rules, you don't always have to go the same way that I do. I might choose to go this route, you might choose to go a different route. As long as we're using correct rules, we're going to be fine. So when I do that, I end up getting 58 for this angle, 32. Go ahead and answer all of these first and then come back and check them. 116, 90, and 58. Okay, this one is very, very similar. I am just going to write the answers down in a minute. So Go through this, label everything you know. Can you answer it? Come back and check your answers right now. Okay, AC should be 42, 21, 26, 33, 90 degrees, 38 degrees, 52 degrees, and 104 degrees. I didn't stress this, but you should put degrees anytime you're looking for an angle, so don't forget that. Okay, if you have questions on that, bring it to class and we can go over that one in class. Now going on to the next page, I am going to do the evens with you right now. I'll give you the answers to the odds so you can check them, but we'll do the evens together. So if you want to pause and work them out on your own first, I strongly suggest that. Okay, if we are solving for a letter x or a side, opposite sides are equal. We're going to do 7x minus 39 equals 3x plus 5. Subtract, I get 4x. Add, I get 44. Divide, I get x equals 11. Now that's not what it's asking me. Make sure you pay attention when it's asking for a different value. It wants me to solve for EF. Oh my goodness, can I pick up a highlighter? It wants me to solve for EF. I'm going to plug 11 in here. 7 times 11 minus 39. 77 minus 39. I end up with 38 for EFE. EF. There we go. Next one here, JM is this length x plus 17. MK is 5x minus 23. The pieces of the diagonal have to be congruent. So we're going to set these equal here. I'm going to start with 5x minus 23 equals x plus 17. Now, you don't have to. You could have done the x plus 17. I'm going to put the 5x over here because now when I subtract the x, I end up with 4x and I have a positive x on the left side. That's how I want my equation to look. It's just easier and nicer for me. Add 23 over here, I get 40. Divide, I get x equals 10. Now I want to solve for JL, which is the whole length. So now what I'm going to do is I'm going to plug in 10 plus 17, and I get 27. 27 is not my answer. 10 is not my answer. I need two 27s. It's 27 here and 27 here. 27 times 2. I end up with an answer JL equals 54. Make sure you pay attention to what it's asking you to solve. Okay, over here, these are alternate interior angles. Remember, you've got parallel lines cut by a transversal. This angle right here is equal to this angle right here. They're alternate interior. I'm going to start with the bigger variable number. So I have 11x minus 3 equals 7x plus 5. I'm going to subtract 7x on both sides. Then I'm going to add 3 on both sides. So I didn't walk through the steps up above, but remember, add, get your variable on one side, get your numbers on the other. Those are going to cancel out. I end up with 4x equals 8. Divide, I get x equals 2. Now, what is it asking me to solve for? It wants me to figure out BCE. BCE is this angle right here. So again, if you can do that one on your own, do it first. This one becomes a little bit tricky because if I plug x in to either of the angles, 11 times 2 minus 3, 22 minus 3, I get 19. 19 is not my answer. It's this angle right here, and these two angles together have to add up to 90. So now I'm going to do 90 and subtract that 19. I end up with 71. So the measure of angle BCE is equal to 71 degrees. If you got that one on your own, good job. This one over here is a little bit tricky too, but I'm going to give you the answers in a moment. Last one I'm going to work out completely is 12. So again, this angle right here is alternate interior to this angle right here. So they are not the two angles I know. I know one of them. Well, this angle right here is alternate interior to this angle right here. What do I know has to be true about the green and yellow dots? They have to add up to 90. There are those angles in the corner, they have to add up to 90. So if this is my green one, this is x plus 20, this is my yellow one, I can add them together, 7 equal to 90. I'm going to do 5x minus 8 plus x plus 20 equals 90. I end up with 6x plus 12 equals 90. 6x equals 78. Divide, I get x equals 13. Not my answer. They want me to solve for x, z, w. I'm going to use a different color highlighter. X, z, w is this angle right here that it wants me to solve for, which is the yellow one. I should have just done that. X, z, w is one that's colored yellow. So it has to be equal to the yellow here. 5 times 13 minus 8. I get 65 minus 8. The measured angle XCW is equal to 57 degrees. Okay, now just so you can come back and check, maybe pause for a minute if you want and then do these other problems. I'm going to give you the answers. So here I have x equals 8 and VT equals 13. Here I have x equals 5 and WT equals 34. Here I have x equals 7 and angle JHI equals 23 degrees. Here I have x equals 12, and it just wants me to solve for x. This one's challenging, so see if you guys can do that and come up with it. Anyway, have a fabulous day. Good luck. I will see you next time.